I'm Ryan Garnett, and I'm the Geospatial Data Manager at the Lakehead University Geospatial Data Center within the Geography Department, and today I'm going to talk to you a little bit about 3D visualization and 3D modeling, but specifically under the term geovisualization. A lot of people consider 3D modeling and 3D visualization in the area of movies and video games like Disney and Xbox and PlayStation. But the type of things that we do are very different. They're grounded in geospatial data, so they have actual real-world locations and they use real-world data similar to what you might see on Google Earth or in Google Maps. So I'm going to kind of explain a bit of the overview process of what we do. And it all starts from raw geospatial data, and that includes three main factors of elevation data, imagery, and vectors. And all these will come together and create a 3D model or terrain. And how that works is we take our elevation model, or DEM, and we take our imagery, which might be air photos or satellite imagery. And these two things come together. So our DEM plus our imagery equals a terrain. And this terrain is going to have our topology features like mountains, cliffs, rivers, valleys. But it's also going to have the color aspect of that area. So if you were to think of Thunder Bay, and if we were to do from the city to the giant, we'd have the lake, which would be blue, the green of the forest, the different colors of the city, and the brown of the rocks. And it would be all extruded, so you would get it to come up, and it would go down, and it would have all its bumps. So these are all our raster data sets that create our terrain. But our vectors are quite important because they allow us to associate 3D models. So things like individual trees might be as points. We can take that X, Y, and even Z information that's stored in a vector and associate a 3D model, i.e. a tree. We can also take different types of vectors that might be polygons that have a surface area, but they'll still have our X, Y, and Z. And this now can be associated to a thing like a building. We also can have line features, which have generally X, Y's, but sometimes they might have a Z value according to the line, and represent it with roadways, or power lines, or railroad tracks. A lot of this all will come together to help create a fully immersed simulation. Finally, when we're building our 3D models, i.e. a building or a tree, we build it with a GPS-based camera. And that camera will record all the texture photo information, but it'll also give us our X, Y, Z of our current location and the camera angle to show us which way that we've been looking. So we can do all our remote filming and photo and field work at anywhere in the world and come back to our lab and create all the models, and they'll be geographically specific and correct. So here we are looking at a model of Lakehead University, a small tile of campus. It's about 500 meters by 500 meters. And all of this data is actual real-world data. So we have aerial photography imagery, about 20 centimeters in resolution, and CAD level drawings of the buildings. And we've taken all this and brought it into a modeling package. And we chose to use SketchUp because it can handle the geographic information, and it allows us to build pretty nice detailed models. So what I'm going to do is I'm going to walk you through about 15 scenes so you can kind of see the little different areas of resolution, parts of campus, and things that we're able to do with 3D modeling from a geovisualization standpoint. So starting here right around the School of Medicine and the ATAC building, we'll walk through campus a little bit here. So now we're walking by the Braun building and the Ryan building, coming up to the Patterson Library, and we're sitting in the RC 2001 room. So these images that you see are actual photographs that have been taken with the use of a GPS camera. The camera that we chose to use was a Ricoh 500 SE. It's about 8 megapixels, has a spatial ground resolution for accuracy in the 3 to 5 meters depending on your location. And what it allowed us to do is go around campus and just take shots however we want it. And there's an actual process that you want to go through to make sure everything lines up. But with it, and the process that we use called geo-feature modeling, it allows us to remove a lot of features and be very accurate and do it in a production mindset that allows for realism. Now you can do a lot of this type of stuff in traditional modeling, such like that you get from Sheridan or you'd get from Seneca. And you see that in the Disney aspect, and they use like a 3D Studio Max. But you get a lot of cartoon look. It's kind of faked. It looks really nice, but when you're going through, it's just the contrast is really high. Whereas when you use actual photographs, you get that difference of the sun reflection, and your eye sees different variations in the billions and trillions of colors. So what really separates the type of 3D modeling that we do here compared to video games and movies is everything's based around geospatial data. And many people ask, well, couldn't anybody just do this? And well, of course anyone can, but what we find in North America and even in the world is there's nowhere really training that. You can go to school and do GIS and remote sensing, like for sure there's lots of schools that do that. And there's lots of schools that do 3D modeling, so you can go and learn how to make character models or entity models for video games and movies. But it's that tying of the two types of data together to create an output model for geospatial and 3D resolution, 3D modeling with a high resolution and great imagery, that is kind of unique. And you're seeing a lot of this in need in industry. Lots of cities are asking for their entire city to be put together. Lots of countries are asking for major states to be put together. And they're using it for security and planning and tourism and lots of interpretive type of processes. So we like to think that we're kind of at the forefront for universities doing this type of packaging. So this is a little bit of our university.
So in addition to doing academic things, like you guys have actually private, these services are available to companies?
Absolutely. We've just recently been working with Parks Canada, and we're doing some work with them to create an interpretive 3D model of the Slate Islands. So not everybody can travel and get out to the Slate Islands, and it's being put in Terrace Bay into their lighthouse. And people can experience the Slate Islands from Terrace Bay as they're driving through Northern Ontario. And we're working with some different private companies throughout internationally to help them with some of the workflows and do some of the modeling and do some of the R&D research that's associated to this level of 3D modeling.
And what's some of your background? Because I know you haven't only worked at Lakehead.
I haven't.
You worked elsewhere, right?
Yeah, when I graduated from Lakehead University in my undergrad, I went to COGS to do remote sensing and GIS, and then upon finishing there, I went and worked for a military flight simulator contractor. And so we would make flight simulators for military purposes, mostly airplanes and helicopters, but we also did some commercial aeroplanes for taxiing around runways to save them money. So apparently if they know exactly where to go, they can save millions of dollars in fuel. So it was all this visual aspect. And from there I moved to another college doing R&D type of research for forest planning. So being able to plan the forest growth and the cutting inside of high areas for visual impact, like tourism aspects. So we would build the whole area in Corner Brook, Newfoundland, in Western Newfoundland, and then show how it would look when it gets cut and grow through different stages of forest growth. And from there, I moved to the United States, and I worked in Colorado for a firm doing this type of stuff from an urban standpoint, and it allowed me to travel throughout the United States, run projects in India, China, Abu Dhabi, and Ireland. And one of the largest projects that I was involved with was, at the time, the single largest non-military 3D visualization work, and it was for India and New Delhi when they were hosting the Commonwealth Games. In 2010, we built the entire city of New Delhi that was 1,500 square kilometers and 3+ million buildings to do this for their planning, security, and then tourism interaction.